Why would that do that? I think I touched something. If I have to record myself on the first part, I will record myself. Sorry about that. Okay, at any point, but there is a catch, where f of x has a rate of change. But we don't like to write this, where f of x has a rate of change, but we like to say where f of x is differentiable. They mean the same thing. So let's summarize this. It's very important. So for f of x, there exists a function that gives the instantaneous rate of change of this function at any point, but exactly where and only when the function has a rate of change. In other words, we say it's differentiable. So when will a function be not differentiable? Not differentiable. In other words, I cannot determine the rate of change. It doesn't exist. In which situation a function does not have a rate of change because its rate of change does not exist. In other words, we say the function is not differentiable. Number one, not continuous. So at these points, from last time, at this point, the function is not continuous. It cannot have a rate of change. The function doesn't even exist. At this point, the function doesn't exist. It's not continuous. It cannot have a rate of change. If you ask me what is the rate of change here, I say sorry. And where is the previous one? Right here. And at the jump, the function does not have a rate of change here. It has a rate of change here, and here, and here, and here, but not here. So when it's not continuous, the function is not differentiable. So, number two, cusp, corner, vertical tangent. So first of all, it's not continuous. I will not be able to give you a rate of change. If it has a cusp, what is a cusp? A cusp is something like between two teeth. This is a cusp. What is a corner? Something like this. Or something like this. Or something like this. These are all considered corners. What is a vertical tangent? At this point, the tangent of this function is vertical. You can also say that here is tangent is vertical as well. So if the function is not continuous, or if it has a cusp or a corner or a vertical tangent, we say the function is not differentiable. In other words, do not ask me to give you the rate of change of the function at those points, because there is none. Okay, so I did already print this out for us. It's an example from the book. Let me show you where it is. Let me share my screen. I hope I'm not logged out. I may be logged out. I'm trying to find the book. Okay, no, I think I'm not logged out, at least not yet. So here it is. So I copied this graph. I printed it and enlarged it as much as I could. Okay, so we're asked here, list all x values for which the function is not differentiable. Okay, so let's see, where is the function not differentiable? So what about at x0 or x naught? is the function differentiable at x0? Differentiable or not?
Differentiable.
Say it again.
Differentiable.
It's not continuous. It's a removable discontinuity. So if it's not continuous, not diff. Good. What about at x1? Differentiable or not?
Differentiable.
Perfect. What about at x2? Differentiable or not?
Yeah.
Perfect. What about x3?
No.
No. Why? Y is not differentiable.
Because it has a corner.
Corner. And here I'll say not continuous. Removable. Discontinuity. Perfect. What about x4?
No.
Same thing.
Not.
Corner. Yes. What about x5?
Yes.
Yes. What about x6?
No.
No. Same thing. Corner. What about x7?
Yes.
It's a tough one. It's a tough one because I see here something like this. I'm not completely certain, but I think it looks like it's continuous. Definitely continuous, but it does not have a corner. I don't know. I don't know if it's something like this or it's just like this. So let's say it's okay. What about here? Differentiable? Can I determine a rate of change here, in other words?
Yes.
Of course. What about here?
Yes.
Yes. What about here?
Yes.
Yes. What about here? Again, if I assume it's like this, then it's okay. But if you assume it's like this, and it breaks and there are two different functions, if you want to say that, or two different pieces, then it's not. So I will say okay. I will say okay. But again, we have to be careful. What about this one?
Yes.
Careful.
No, vertical tangent.
Yes. Vertical tangent. So x12, vertical tangent. Not differentiable. Perfect. Okay, now, here's the next very important topic. F of x given. Find the function that gives the rate of change. Of f of x at any point, of course, where it's differentiable. At any point. I'm going to just put in parentheses differentiable, so you know what I mean. Not these points. We're not going to call this function like that anymore. We're going to call it by its name. F prime of x. F prime of x. Or the derivative of f of x. So instead of saying, find the function that gives the rate of change, the instantaneous, of course. Find the function that gives the instantaneous rate of change of f of x at any point where it's differentiable. No, 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 we're done with that. We're going to call it f prime, in short. F prime. When we say f prime, we mean the function that gives the instantaneous rate of change of the f of x at any point. But again, this is too long. We call it f prime. Or if you don't want to call it f prime, you can call it the derivative of f of x, or the first derivative of f of x. Okay, how do we find it? And that's my page 4. So we can quickly determine the rate of change just plugging in f prime. So how to find f prime of x? This is the biggest target here in this class. How to find f prime of x? So number 1, possibility, and number 2, possibility. There are 2 different ways. Number 1, using the definition of f prime of x. Hard. Not too hard, but I want to say hard so we know exactly what we mean. The hard way. What is the other way? Easy way. The easy way is using differentiation formulas or rules, whatever you want to call them. But first we have to do it the hard way. And then we're going to look at differentiation formulas. Okay. So what 2 major, I'm looking at the video, it's okay. 2 major concepts that we studied so far. Maybe new concept. 2 major, huge concepts that we've discussing in the last 3 weeks. What do you think? I was debating with myself to use 1 or 2 or AB. 2 major concepts that I've been torturing you with in the last 6 classes.
Limits.
Yes! That was a big concept, big, and it's an operator. It does something to a function. It finds where it's going. Not the value, but what do the function values approach? Perfect. What is the other big concept that we looked at? And I said this is so important, and we looked at 3 different functions. And we determined it, and we evaluated it, and we looked at 3 different functions: polynomials, rationals, and radicals.
Average rate of change?
Yes, difference quotient. Very close, yes. So these 2 major concepts are basically what we discussed. Everything else is a little bit of here, a little bit of there, important, but these are the core concepts in the last 3 weeks. How to deal with limits, and we looked at so many different situations, and how to find, simplify, and determine the difference quotient. Anyone remembers what is the formula for the difference quotient? Very important formula.
F of x plus h minus f of x divided by h.
Excellent. This is a difference quotient. Thank you so much. Was it John?
It was Garby.
Garby, thank you so much. Excellent. So f of x plus h minus f of x over h. Good. Well, all I'm going to do is just put this concept in front. As h approaches 0. This is it. This is the definition of the derivative function. These 2 concepts put together. That's why initially we talked about the algebra and we did the difference quotient. And then we talked about this new concept of the limit. And now we are putting these 2 together to make this function. And you understand now why this function may not exist. How come? If the limit doesn't exist, the function doesn't exist, which means the original function is not differentiable. Because we know that we found many limits that did not exist. The answer was infinity or D and E. So if this limit does not exist, the derivative does not exist, which means the original function does not have a rate of change because it either has a cusp or a corner or a vertical tangent, assuming it's continuous. Okay? Excellent. So now you make up a function, any function you want, and we practice finding the derivative of that function that you come up with using the definition. This is the definition of the derivative. It's the hard way. The easier way will be this. So we can, I can open the book. I share my screen, and you can choose a function from here, or you make up one.
Can we do it using the homework question from yesterday?
Yes,
Why
any
Where
yes, any function you would like to work on. So hold on one second. Let me
5x plus
hold on
5y.
one